So this is lesson 8 in the quantitative chemistry set for year 10, new GCSE. So starting this lesson by showing you a load of glasses of blackcurrant squash and asking you how a year 7 would describe that to you. So one of the things you learn about in year 7, keywords I'm going to throw at you are solution, solute, and solvent, which are 3 ideas that you learn about in year 7. So what I'm looking for in this is that actually you have, in this cup here, you have more solute in the same amount of solvent. In this one you have less solute in the same amount of solvent. So what's interesting is the ratio of your solute to solvent. Okay, that's what you're seeing here, and this is what you're familiar with if you make squash. So the topic here now is called solutions calculations, and you'll need to be able to describe the relationship between a mass of solute, volume of solution, and concentration. I'm going to use a new equation which is C equals N over V, or if you want to write C equals N divided by V, but I really don't like that. I'd rather you wrote C equals N over V. And you need to be able to convert between centimetres cubed, sorry I've lost my superscripts there, and decimeters cubed, so you need to understand what those are, and I will explain that to you. So I'm back to my glasses of blackcurrant squash, and you can do worse than think about all of this in terms of blackcurrant squash. That will help you get your head around it. So what we call concentration is how much solute there is in the volume of solvent. So going back to the thing we talked about right at the beginning, is saying is the ratio of solute to solvent is basically what concentration is. It's a measure of how much solute is dissolved per unit of solvent. So, as I've said to you, the equation is C equals N divided by V. Now, you have to have N is your amount of solvent in moles usually, but sometimes in grams. I will explain both to you. Your volume in solvent has to be in decimeters cubed, okay, and I will explain what a decimeter is in a minute. And so your concentration is therefore measured in moles per decimeter cubed. Now, and what I would prefer you to write with this is to write it as this, moles decimeter to the minus 3, okay, because if you think about it, a mole divided by a decimeter cubed, you know that if you want to bring this term up to the top, you just need to make the index negative. I hope you've learnt that in maths. So what we're looking at here is we've got lots of solvent, less solute, low concentration, lots of solute, less solvent. Well, actually the same amount of solvent, actually, if you look at that, the same volume, but high concentration. Now, my next question is, what is a decimeter cubed? Okay, now, a decimeter. If you've done some ancient Roman history, there's the story about decimating armies. I'm not sure this necessarily did take place. I'll need to go and check up my history. But if a unit was found to be mutinous or cowardly in the Roman army, 1/10 of the soldiers would be executed. So, deci means 1/10. Okay, so 1 decimeter is 1/10 of a meter, which is 0.1 meters, or it's 10 centimeters. Okay, so we need to be able to calculate the difference. We need to be able to convert from centimeters cubed to decimeters cubed. So I am going to draw a cube that is 1 decimeter cubed. Okay, so that's that big cube here that I'm outlining right now. Because a decimeter is 10 centimeters. So a cube that is 1 decimeter cubed is 10 centimeters by 10 centimeters by 10 centimeters. Okay, so it's 1 by 1 by 1, 1 decimeter cubed. Okay, so full equals 1 by 1 by 1 decimeter cubed. But if we want to work out how big that is in centimeters cubed, we need to use the centimeters in there. So it's 10 by 10 by 10 centimeters cubed, which equals 1,000 centimeters cubed. So you can either learn this if you found what I just did tricky, or hopefully you might see why that is the case from that picture. But 1 decimeter cubed is the same as 1,000 centimeters cubed. So we're going to do an example. First example is going to be using grams. Okay, so I've got formula triangle. In this case, I've got C equals M over V. C equals mass over volume, okay, rather than C equals N over V, which is number of moles over volume. In this case, what's the concentration of 50 grams of NaOH in 250 centimetres cubed? Right, so grams, we're happy with that, but we are not happy with 250 centimetres cubed. So we have to use what we just learnt, is that 1,000 centimetres cubed equals 1 decimetre cubed. So 250 centimetres cubed is 0.25 decimetres cubed. Okay, so simple, fairly simple calculation at that point. Okay, so concentration equals 50 divided by 0.25, which comes out at 200 grams per decimetre cubed. Or, as I said, I'd rather have you write this, but if you're not familiar, if you're not comfortable, then at least get the units right. Okay, 200 grams per decimetre cubed. What else was I going to say about this? So the grams comes from here, so you bring that straight down here, and decimetre cubed is the unit that volume is in. So let's try an example with moles. So here's a nice example with moles where they've already told you how many moles we've got. Now, on our earlier example, we decided already that 250 centimetres cubed was 0.25 decimetres cubed. This is 0.75 moles. Okay, so C equals N over V. So actually, I'm writing this out again. 0.75 divided by 0.25, which is 3 moles per decimetre cubed. Now, the only thing they can do to make this a little bit more tricky is perhaps to give you the amount of NaOH in grams. Oops. Okay, but ask for the concentration in moles per decimetre cubed. That's actually relatively straightforward now based on what you know, because you know how to turn an amount in grams into an amount in moles. You have to use mass equals mR times mole. So mole equals mass over mR. So if they gave you an amount of NaOH in grams, they asked it for moles per decimetre cubed, you would take whatever your mass is, and then you would divide it by the mR of NaOH, which you get straight from the periodic table by adding the mass of sodium, 23, plus the mass of oxygen, 16, plus the mass of hydrogen, which is 1. So it gives you a number of moles, and then you can calculate it in moles per decimetre cubed. Right, I'm going to have a quick word here about terminology. All the way through school, you've talked about strong and weak solutions. This is actually taken out of a textbook, and you can see, look, I've stuck some words over the top. It says strong and weak solutions. Don't use the word strong and weak. Use concentrated and dilute. Okay, so sugar solution is dilute, it's not sweet enough. Sugar solution is too concentrated, it's too sweet. Okay, so please don't use strong and weak. When you get to A level, they have very special other meaning. So I want you to get used to using the word concentrated and dilute instead.